Welcome to the presentation. So this becomes the basic PIC 16 microcontroller. So in this process of addressing this microcontroller, we see the basic first level of architecture. The basic first level of architecture deals with three important areas to be considered. One is about how the input parameters are set up, and second is about how the memory is being utilized, and third is about how the operation of memory as well as input are being taken in a place of arithmetic logic unit. Okay, let us start from basics. First, we deal with ports. Ports are the fundamental and basic thing where input and output parameters exchange themselves for creating internal as well as external data transfer. So one such form is with register. That is, it starts with register B0, and it initiates with B1 to B7, and then from A0 to A3. These are the 4-bit, 8-bit input output ports. The 4-bit and 8-bit input output ports are governed in such a manner that all these things will create a relatively superimposing data transfer. What is superimposing data transfer? In the sense, within that area only you need to deal. Other than that, you should not deal anything related to that. And this is being connected to arithmetic logic unit. Here we have ALU unit. This ALU unit is directly flowing to W register. So W register is generally the write register. That is, whatever value you need to write, you need to first initiate it. That means that first each and every idea is a singular structure. What is a singular structure? An instruction which is being sent to the processor and to the memory and to the port or through timer. Everything deals with one idea, that it is a read and write mechanism. So what is the read and write mechanism? Primarily, a microprocessor contains 0, so we need to read the value whether you have 0 or not. So definitely it has some 0. Then we need to 0 in the sense there is nothing like 0 is present in the memory space. Actually, if you enable 0, it will read the data from the memory. That is the idea. Read 0 means it will go to the memory and it will read what is there in the memory. So it has some value. Okay. Then write. If you enable write 1, what will happen is you are going to load a data into the memory. So loading a data into the memory is termed to be write 1. So definitely an arithmetic logic unit will give memory storage. That is, 1 is enabled and it is put it into the memory. Okay. And after that, this write register is directly loaded to the arithmetic logic unit for the process. So coming from this area, so where does these two get initiated? Mux is many to one mapping. Obviously, we need many data communication paths to establish a single ALU operation. So what that part? First one is, I have already stated in the class that arithmetic logic unit, if it need to perform, it should fundamentally have an idea of how instructions are being loaded inside and how the data is being retrieved. To store the instruction, sorry, to load the instruction and process the instruction, the fundamental thing we need is program counter and a stack pointer. So program counter and stack pointer, what it will do is it has the provision to work on with flash or ROM program memory space as well as EEPROM data memory space. So program counter using stack pointer, it will load the instructions either in flash or ROM or EEPROM depending upon the usage of the program, and sometimes in the RAM too. So all these things are memory spaces 1, 2, 3. All these things are memory spaces loaded in variation with the process of utilizing arithmetic logic unit. I hope you all understand this, because program counter through flash or prom will give program bus, and this program bus will directly give instruction to the mux. So instruction is directly passed to mux, and data bus is directly passed to bus, which means that address bus and data bus both combine together to form an arithmetic logic unit operation. So what that means, every process in a microcontroller will utilize address bus and data bus. So address bus and data bus together contribute the process of operation in a arithmetic logic unit. So data bus is governed by RAM, EERAM, and sometimes with respect to FSR and status. What is FSR and status? This is file select register, which actually deals with interrupts. So what is this interrupt? Every program is running with address bus and data bus, that is data and instruction. If suddenly a process or an issue appears, the things must respond to the event in such a manner that it should give high priority for the instruction. So a high priority instruction set will run, and the program for it is embedded in the microcontroller. So for that, what we need is file select register and direct registers. So file select register and direct register, when combined together in a mux, it will contribute to RAM, which means that we should come in reverse. So whenever a program is being executed, it will check whether it is an interrupt program or normal program. It will state it as whether interrupt program or normal program. If it is an interrupt program, let us shut down all the unnecessary memories and let us go directly into the RAM and work for it. If it is RAM means is an execution program. If it is a data and address process, then we can utilize EEPROM and ROM. So, on the whole, the microcontroller has two idea of executing an instruction. So first it executes through the consideration of whether it is an interrupt or not, and after that it executes through data and address. So all these steps are planned, executed, and synchronized by this area. So, what is this area? This area contains the watchdog timer, power on reset, oscillator startup timer, power up timer, which means that a timer generated through an oscillator is the initial process of fixing a timer. Example, an oscillator is a crystal oscillator. It creates some undamped, overdamped, and damped oscillations. All these oscillations will result in creating have fundamentally 8 megahertz or 12 megahertz signals. We will continue other things in the next video. Thank you.